Welcome to week one of CME 610, Data Science in Education. I'm Dr. Bria Ratliff, and I'm excited to begin this journey with you because this course sits at the intersection of several important conversations happening in math education, educational research, technology, and society more broadly. This week, we're going to focus on the foundations of human centered data science in math education. And one of the key goals of this week is to begin developing a shared understanding of what educational data science actually is, what it can do, and also what its limitations might be. So, throughout this course, we're going to continually return to one major idea, and that is that data are not neutral. Data are created, they're collected, they're interpreted, they're visualized, and communicated by people. So, because of that, data always reflect human choices, assumptions, priorities, and our values. In many educational conversations, data are treated as objective truth. And we hear phrases like the data say or the numbers prove. But part of our work in this course is to slow down and ask even deeper questions like who collected the data? What was measured? What was not measured? Who benefits from the conclusions being drawn? And whose experiences may be hidden or erased? As doctoral students in mathematics education, your role is not simply to analyze data technically. Your role is also to critically interpret educational data in ways that are ethical, equitable, and human centered. Educational data science is an interdisciplinary field, so it draws from statistics, mathematics, learning sciences, educational research, technology, and increasingly from fields connected to artificial intelligence and computational analysis. In some settings, data science is framed primarily as coding, machine learning, or predictive analysis, analytics. While those areas matter, this course approaches data science somewhat differently. We're interested in educational data science as a tool for understanding learning, supporting students, improving systems, and critically examining educational opportunities as well as inequities. So, educational data science includes questions like how do we interpret patterns in student thinking? How do we use classroom evidence to inform instruction? How do school systems use data to allocate resources or make decisions? How do public narratives about achievement and failure get constructed through data? This course is also intentionally human centered. That means we're not treating students as numbers or abstract variables. We're recognizing that educational data represent real people and communities, our experiences, histories, and so on. As mathematics educators and researchers, we're responsible for thinking carefully about how data practices impact the learners and their communities. Mathematics education has a critically important role to play in the age of data science. Historically, mathematics education has often emphasized procedural fluency and symbolic manipulation. And while those skills matter, students today also need opportunities to interpret data, evaluate claims, critique visualizations, and reason statistically in public and civic contexts. Hardin and Horton raise an important question in this week's readings. What mathematical preparation should students have in a world increasingly shaped by data science? That question matters not only for future statisticians or computer scientists, it matters for citizens, teachers, policymakers, and community members. Students will encounter data constantly through social media, through elections, economics, public health information, educational dashboards, and news reporting. And if they're unable to critically interpret quantitative information, they become vulnerable to manipulation, misinformation, and inequitable systems. So, this means that mathematics education cannot just be about solving equations, it's about helping students become critical interpreters and communicators of information. This week's foundational readings help establish the intellectual direction of the course. In the first column, that article will introduce statistics education as an emerging discipline focused on reasoning, interpretation, and literacy rather than simple computation. Their work helps us understand that statistical thinking involves making sense of the uncertainty, context, variability, and evidence. In the second column, these authors write an article that helps us to think about mathematics education and how it has to evolve in response to data science. They challenge educators to consider what knowledge and experiences students need in order to participate meaningfully in a data rich society. In the third column, these authors provide an equity centered perspective on mathematics education. So, one thing I appreciate about this reading is that it reminds us equity is not a fixed and or a simple concept. Equity work requires ongoing reflection about power, access, opportunity, and justice. So, as you engage with these readings, I want to encourage you to think of them not as isolated articles, but instead think about how they're speaking to one another. Where do you see overlap and tension? And what assumptions about mathematics and data are being challenged? One of the most important conceptual ideas in this course is that data are human constructions. Sometimes people talk about data as if they simply exist naturally in the world waiting to be collected. But in reality, people decide what counts as data, what categories to use, what questions to ask, and again, what gets measured. For example, think about our educational accountability systems. Schools may collect standardized test scores, attendance rates, graduation rates, or discipline data. But what about student belonging, joy, identity development, or cultural knowledge and creativity, or even community engagement? What happens when educational systems prioritize only certain forms of evidence while ignoring others? Those decisions shape our educational narratives. They influence policy decisions, public perceptions, teacher evaluations, and funding structures. So, this idea becomes especially important when we think about historically marginalized communities. If data systems fail to capture the experiences and the strengths of certain groups, those communities may become invisible within the decision making process. So, throughout this course, we're going to examine not only how to analyze data, but also how data systems themselves shape educational realities. Equity is not an add on topic in this course. Equity is central to how we think about educational data science. As mathematics educators and researchers, we need to ask critical questions about representation and visibility. Who was represented in data sets? Who was excluded? What assumptions are embedded in educational metrics and assessment systems? Educational data can absolutely be used to support learners and identify inequities, but data can also reinforce deficit narratives and harmful assumptions. For example, achievement gap discussions sometimes focus only on what students supposedly lack, rather than examining systemic inequities in access, resources, opportunities, or representation. A human centered and equity oriented approach challenges us to move beyond deficit interpretations. This week, I want you to begin thinking about how educational data can either support justice oriented work or unintentionally reinforce equitable systems. A human centered approach reminds us that educational decisions affect real people and communities. Human centered data science asks us to think carefully about ethics, relationships, interpretation, and consequences. In technical fields, there can sometimes be a tendency to focus heavily on efficiency, prediction, or optimization while overlooking the human impact of decisions. This course pushes against that tendency. For example, predictive analytics tools may claim to identify which students are at risk, but what assumptions are built into those systems? How are labels assigned? How might those labels affect opportunities for students? Human centered educational data science requires humility, reflection, and ethical responsibility. It also requires us to recognize that communities possess important forms of knowledge and expertise that may not always appear in our traditional data sets. As researchers and teacher educators, we must think carefully about how our work impacts learners, teachers, families, and communities. Today, everyone encounters data constantly, and we see graphs on social media, statistics and news reports, visualizations during elections, and quantitative claims in public debates. But simply seeing data doesn't mean that people understand or critically interpret those data. Statistical literacy involves more than calculation. It includes interpretation, questioning, skepticism, communication, and contextual reasoning. Students need opportunities to ask questions like, what does this graph actually show? What information might be missing? How were these categories defined? And what assumptions are being made? So, this is why mathematics education matters so much in civic life. Mathematics classrooms become spaces where students learn to analyze information critically and participate thoughtfully in society. One of the major goals of this course is to think about how educational data science can support not only academic learning, but also civic understanding and democratic participation. This course is designed to be intellectually collaborative and inquiry oriented. So, throughout the semester, you will engage with scholarly readings, complete Quant Hub modules, participate in discussions, write data reflection memos, and work toward larger inquiry and visualization projects. The reflection memos are especially important because they give you opportunities to connect course concepts to your own experiences, your professional contexts, and emerging research interests. I also encourage you to approach this course with curiosity and openness. Some ideas may challenge traditional assumptions about mathematics, data, objectivity, or educational systems. That discomfort can actually be productive for learning. The goal is not simply to accumulate technical skills. The goal is to develop thoughtful, critical, and ethical approaches to educational data science. As we close this week, I want you to continue reflecting on several important questions. What counts as data in mathematics education? How do data shape educational narratives? Whose experiences become visible through data systems? How can mathematics educators use data ethically and equitably? And what responsibilities do researchers have when working with educational data? These are not simple questions, and we will continue revisiting them throughout the semester. I'm looking forward to learning alongside you and engaging with your ideas in the discussion boards and reflection memos this week. Please reach out if you have questions, and I hope you enjoy beginning this journey into educational data science together.